everyone, we are going to present you our research about image classification for men and women classification. First of all, I will introduce you myself and my team members. My name is Aisyah Binti Azman. My first member is Abdul Rafi bin Ramli, and second Ihsan Bin Zulbahri, and the third Ahmad Adham bin Ahmad Zailan.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Rafi and I will be presenting the introduction and objective of the report. First and foremost, our project focused on image classification to classify men and women based on images. This is because gender recognition is crucial in the modern days in improving the effectiveness of surveillance system and many more. In our project, we import the image that we want to classify to the system. The system will then recognize the image according to their labels. Finally, the output will be produced based on training and testing data that have been used. To get the best and highest accuracy, we conduct several experiments, which later will be explained by Ihsan. Moving on to the objective of the report. The objective of the report is to identify and classify human gender, whether it is a man or woman, using artificial neural network based on images. Later on, Adham will explain more about artificial neural network or AN architecture.
Hi, my name is Aisyah Hida. I will explain to you about scope of report. First, our data was imported from Kaggle. It is consists of two categories, which are men and women. It is contain 4,223 data. Then it is divided into two, test data and train data. In train data, we have 2,893 data. In test data, we have 1,330 data. Then we set up image size to 80 times 80 pixels. We change image from 3D to 2D array and convert color image from RGB to grayscale. I will pass to Abdul Rafi to explain detail about the objective of this report.
Assalamualaikum. My name is Ahmad bin Zailan, and today I will present about network architecture. In this experiment, we use convolutional neural network, which include in artificial neural network. This network architecture consists of input layers, two hidden layers, and output layers. There is 80 times 80 inputs, which is a total of 6,400 inputs, and 100 hidden nodes or hidden network in each hidden layer, and produce 2 digit output, which is 0 or 1, which represents male or female. Next is the model summary. This is the model summary after we run several parameters. From the sequential model, there is flattened layer which transform the two-dimensional into the vector, so the neural network classifier can read it easily. The flattened layer shows 6,400 feature space width due to the 80 times 80 inputs. Since the hidden layer contain 100 neuron linked to 100 weights, the coefficient of the first dance is 640,100. That gets from the 6,400 times with 100 plus with 100 of the bias value. Same goes to the coefficient of second dance, that get the total of 10,100. The output layer will be 2. It will be either 0 or 1, which means it is either the male or female. That's all. Thank you.
We will proceed with the Jupyter session, which I will explain the whole sequence and how we run the data. So first of all, we import the module TensorFlow, NumPy, Matplotlib.pyplot, OS, and CV2 in our coding. Next, we import the man-woman datasets, which the dataset contains 4,223 images in two categories. So first of all, we have the two different directories for train data and also test data. as I said before, we have two categories, which is man and woman. The resolution for the pictures is 467 by 700 pixels. So as you can see here, this is the image. It's very clear and perfect picture, but we change it into grayscale so the coding can learn the image faster. So here is the shape or pixel for the image. Then we small the image in 80 times 80 pixel. So you can see here it is a little blurry, but the computer still can learn from the images. So here we compute the train data and source test data as a directory to load the images in the coding. Next, how we explore the data. As you can see here, the train data, there are 2,893 images, while the test data is 1,330 images. Then we process the data by using import random, which we shuffle the train also the test data sets to be in a random sequence. Next, you can see this here for images in labeled in train data. S1 and I1 is images and labeled in the train data, while X2 and Y2 is the images and also the label in the test data. Then we use import pickle to load every images and also the labels into the coding. So here you can see scale these values to range 0, 0 to 1 before feeding them to the neural network model. Do so, divide the values by 255. So here the train and image is divided by 255, which 0 represents the black color, while 255 represents the white color, and between is the grey color. Then we display the first 100 image from the training dataset and display the gender name below each image. As you can see here, there are 100 images of men and women, which is in the random sequence. Then we build the model by setup the layer with Keras sequential, Keras.layers flatten, Keras.layer dense. In the Keras.layer flatten, this is the input for our data. For Keras layers.dense, we have two hidden layer, which this is our change hyperparameter. For the neuron, we have 100 neuron, which is our constant hyperparameter, as well as the activation function, which is we use the ReLU function. This is also our constant hyperparameter. And the last Keras layer.dense is our output, which we only have two output, which is man and woman. Next, we compile the model using Keras.optimizer.Adham. We use the hyperparameter Adham, optimizer Adham, which is also a constant parameter, while our learning rate is our change hyperparameter, which we use 0.1 in this demo. For loss function, we use sparse categorized cost entropy, while the matrix we use accuracy to evaluate the accuracy of this test. In the model summary, as you can see here, this is our model summary. Then we train the model. For in the training model, we use 200 epochs to train our model. So as you can see here, we have run, and for the training set, we achieve 0.9630 of accuracy, which is very, very good, which the computer can learn from the images. When we evaluate the accuracy to compare how the model performs on the test data set, we found out that we achieve 0.78 only in this test data set, which is not that bad, but it cannot if we compare with the trained data set, the trained data set have a higher accuracy. Then we try to make a predictions here. So here we plot the images to look a full set of two class predictions. So when we predict the images of number 48, we achieve correct image. But when we try to predict the image of number 45, the computer didn't learn that the image is a man, but instead it said it's a woman. So here we can see a few images, which is 12 images that the computer try to learn and run to see if it can classify is this a man or woman. So this is the last part of our Jupyter session.
That is all from our group. We hope that you all enjoyed and received lots of information from our video. Thank you.